Hello everyone. In this video I am going to demonstrate a differential amplifier with transistors. So as you can see, this is my setup. This is how the setup looks like. So as you can see here, these are the two transistors and I am taking a differential voltage between the two transistors to the speakers. So this is how the setup looks like. The setup is wired on a breadboard. Here you can see these are the two speakers for the output and these are the probes for the measurement. So as you can see here, these are the biasing resistances for the circuit and these are the coupling capacitor. This is the coupling capacitor to the speaker. We are not feeding DC voltages directly to the speaker. We are using coupling capacitors. This must be used because speakers cannot handle heavy DC voltages. So if there is any error fault in the circuit, the speakers will damage. That's why these coupling capacitors are used to feed only AC signal to the speakers. So this is how the setup looks like, and I am feeding signal from my cell phone to the circuit. Let us play the circuit. We will be observing the results. Now let us look into the circuit diagram. So here as you can see, this is the circuit diagram. So here you can see these are the two NPN transistors, SL100 I am using. SL100 transistors I am using. So this is the far view of the circuit diagram. So here you can see this is the far view of this circuit diagram. So here as you can see, the base is biased with a 100k resistance fed from the collector. So like this there is a biasing. I am feeding the collector with a resistance of 4.7k. So this is how the circuit looks like, and both the emitters are connected together with a 100 ohms resistance followed by a multimeter. This is used for measuring the current in the circuit. This loop is used for measuring the current in the circuit as well. So between the two collectors I am measuring the voltage on a voltmeter. So this is how my setup looks like. So now we will be observing the results when there is no audio signal. So when there is no audio signal, the collector current, the emitter current is 8.68 milliamps DC. So here you can see this is the emitter current. The current from both the emitters, this current is 8.68 milliamps at present. And here you can see this is the voltage between the two collectors, 1.01 volts. So this is the voltage between the two collectors at present. This is 1.01 volts when there is no signal. You can see here this is the result when there is no signal. So now you can see here. So now if we increase this resistance, suppose we are increasing this resistance, we will be observing the gain in the circuit. So now I have increased this resistance, increased it, and I have made it 200 ohms. So now you can see the current has reduced. It has become 8.34 milliamps, and here you can see the gain also has reduced. The voltage difference has reduced. I mean, it is 0.99 volts. It was more than 1 volts before. So now it has reduced a little. So like this, if we increase this resistance, the differential voltage gain will reduce also. It is recommended to use a constant current circuit in this loop so that the gain of the amplifier is constant. Let us play the audio file again. So this is how my circuit works. Thanks a lot. Thanks for watching. In the next video, I am going to enhance this differential amplifier with a second stage differential amplifier. Thank you very much. Please watch the next video.